Hello, my name is Simeon Branch-Eason, and I will be exploring how physics principles are used and misused in contexts such as military technology and public policy. I will be discussing the physics behind nuclear weapons and the global politics of deterrence. So the physics for a nuclear weapon is the binding energy, which is the energy released when a heavy nuclei is split, such as for fission, or light ones are fused for fusion. The basics of fission is a neutron is absorbed by a fissile material and it makes the nucleus split in two, releasing a burst of energy and stray neutrons to continue the reaction. If if the fission triggers another, and it usually leads to a self-sustaining reaction called criticality. Critical mass is when enough tightly packed fissile material with the right shape, density, and purity keeps the neutrons from escaping, so the chain reaction continues and runs away, which is called supercritical. From the physics to the bomb is fission weapons are a rapid assembly of supercritical mass, often using high explosive compression, which releases significant amounts of energy. Fusion weapons are a two-stage system that use a small fission to compress and ignite the secondary, where the fusion adds far more energy. The core, the core ideas of deterrence. Did it freeze? The core ideas of deterrence are to prevent an attack by credibly threatening an unacceptable level of retaliation. The second strike capability is surviving the first strike and still being able to retaliate. This is the backbone of MAD, which stands for Nuclear Mutually Assured Destruction. A part of this is the nuclear triad, which is land-based ICBM silos, submarine-launched ballistic missiles, and long-range bombers. A case study of when MAD should work would be Ukraine. Ukraine had the third largest stockpile of nuclear weapons at one point in time. But due to several factors such as the large expense and the chaos of the collapse of the Soviet Union, Ukraine gave up all 2,000 of the strategic warheads plus thousands of tactical weapons and the delivery systems. To facilitate this, the United States, the UK, and Russia pledged to respect Ukraine's sovereignty and borders and refrain from the threat of force, and in return, Ukraine would accept and accede to giving away all the nuclear weapons for financial support. However, as we can see, as we're in the future, in 2014, Russia seized and annexed Crimea after invading it with masked individuals, and in 2020, Russia launched a full-scale invasion on February 24th. This shows that deterrence is powerful, but once you no longer have the ability to enforce it, then someone who does can do what they desire. This shows a message to non-nuclear states that as long as they don't have nuclear weapons or don't have anyone willing to use it on the behalf of them, they'll be vulnerable to all nuclear-armed states. The ethics, legal, and societal dimensions are the humanity impact and the nuclear taboo due to the catastrophic civilian harm from the blast, radiation, and heat, which underpins a long-standing gentleman's agreement between all nations not use nuclear weapons unless the countries die at stake, such as if they're falling or they're being invaded and they're about to be conquered entirely. The laws and norms are the several UN resolutions to reject Russia's invasion of Ukraine and any land grabs or territorial claims they purport. They emphasize Ukraine's sovereignty and the fact that they own all the land they have. The political trade-offs of keeping nukes versus giving them up are, for the pros of possession, you are extremely unlikely to be invaded ever again once you get them, and you can use them to pressure your neighbors or pressure those around the world. However, the cons are financial and technical burden. Nuclear weapons are extremely expensive and they require a constant and consistent level of technical knowledge and maintenance to keep them up at all times. There are risks of accidents, and you have to dispose of the waste. And there are sanctions and counter-proliferation responses if you're a new country trying to reach into the big boys club, basically. Science versus society. The scientific foundations are robust and well tested. Their effects are quantifiable and easy to understand for the general population. The society and political use turns hinges on how less on how big the arsenal is, more on if you have them in the first place. The lesson we learned of Ukraine is trading nuclear arms for assurances and funding has exposed a quite big gap when a guarantor, such as Russia, who stated that they would not invade Ukraine at all in the future, becomes the aggressor, such as when they invaded Ukraine. In conclusion, this simply demonstrates how tension between physics of nuclear weapons and the politics of deterrence are in conflict.